this. Oh, hello. Okay. Yeah, I think we can. Is it coming off or what? Oh, that's not the one. Let's change this. Is it C? No, no. Are we on? Yes, we are on. The main camera is Brio. Okay, so the Brio is not showing. Let's try this one. And let's turn the Brio on. Where is Brio? Where are you, Brio? Settings, output, audio. No, let's just have USB. That's better. Apply video. Okay. Select stream. Yes, that's the one. And the video here. Properties. Brio. Yeah, play Brio. Show me. No. No, Brio. Yeah, okay, well, it works. Although I don't like this this mask. I think this is, we do it here in filters. Yeah, filters. And then change this to something less bad, less crappy. Yeah, that's the one. How can I move this around? No. I wish it had a bit more. Yeah. Yeah, so I forgot. I didn't prepare my LeetCode Google Inter. Like twice. Mostly, I see them mostly as a waste of time. But Google people, very important. So let's prepare. I can fail. It's prepared to now. Yeah, I don't feel like I will actually get any job from them. Yeah, I don't feel like I will actually get anything from Google. It's just there to actually have a fun, have a play, and see if I can do anything. The thing is, like, yeah, as I said, like I learned algorithms like twice. Or pass with grace. Yes, or yeah, I think I'm more likely at this moment. I'm just not that well prepared in, because it's algorithms mostly, and you know, so you have to bubble sort and stuff like this, and I actually never use them. You know, I learned them maybe like I remember like learning them 2 or 3 years ago, and then like I never used them. I think like there was one time in my career where I think like if I knew maybe some more efficient sort, like yeah, maybe bubble sort or something, if I knew it actually pretty well, that might be useful, because we had those in one project, we have those D3 charts, and we were getting data from the backend. Like, to be honest, if I was a bit smarter, I would just ask my backend guy to actually send me better data. But then I wasn't that smart. I guess, like, you know, I made a mistake there. So, you know, instead of getting asking like a backend to to reformat the data that he was getting me, I had to actually do it on the front end, and it was like it would actually block my browser for like a second or two, and probably I could send it to the second thread and maybe forget about even playing with algorithms. If I actually wrote an algorithm there, like a proper one, not just because I was doing like a very silly sort, like I was doing like a just JS, sort like map sort or something, or something like that, or maybe even like for each or something. Like I wasn't doing more sufficient sort, so it was actually kind of blocking a browser for like a second. So if I knew that, I actually probably would do it better. So if I knew algorithms then, but the thing is, like, we lost the client then, not because of algorithms or efficiency of the application, but we didn't speak to the client. We didn't ask him what you really want, what you really want, like Spice Girls would sing, what you really want. So we lost the client, and not because the site wasn't efficient or something, not because algorithms weren't there, because we haven't spoken to a guy. I'm supposed to play some music. Should I play music or like, okay, let's just have it quiet in the background somewhere. Yeah, let's have dancing girls in the background. And not to worry. But yeah, basically, maybe it will actually distract me, but do I care? Yeah, so, or will pass with grace. I don't know. Yeah, I think it's unlikely. Yeah, nice to see you. I think you're a new guy. So yeah, I think like it's very likely that it's not gonna go well, and I'm not that worried about that. I don't really want to go to Google too much. I think it's like, the thing is, like, I'm like a father, and I have to pay bills and stuff. So that's why Google job would probably be okay. But on the other hand, it's another one of those like huge factories of code where you just like, when people don't question what they're building, and they're just like building it because with some bubble sort, because this is the only way you can do it, instead of just like seeing if really clients like that. So they will be like spending extreme time to actually I think the role is not really, they didn't like, I think it's like a software engineer, like a general. They would actually, like, based on like how well I would go, or how they would like me or something, I would be assigned to write to the correct team. But I don't know. Seriously, I really didn't care too much, so yeah, I think it's like a programmer. Like, I don't think it's a front-end developer. I think it's like a software engineer or something. So something like that. But the thing is, like, the problem is that you get lots of really smart people who can do math and algorithms and program the shit out of the app, but then they will not ask the client, and they will just spend months actually toiling with something that is not needed. So that's actually, I think this is the bigger problem of software development, not the fact that people don't know how to write a code, or how to write an algorithm. It's about, okay, no one is asking how to actually no one is asking how to do things, how people, what do people want to build, and they just like asking, okay, how we can optimize thing that is not really, we don't know if it's needed even. And like, it's like, I realize sometimes that it's actually much easier to go to your junior and tell him that you have to learn this to actually write than to work efficiently. We have to learn this algorithm because it's important. But then like a senior like that will not speak to his manager asking like, is this like really important? Should we build it? Do you really need it? Like, or how should we build it? Or if the manager will not do his job correct, will not prepare well, like will not plan, there will be abuse downwards towards the junior. Okay, you didn't know the code, you just you wrote let instead of const, you're not changing this variable here, so it's const, and you will get that kind of stuff instead of just like, okay, what's really wrong? Why this project sucked? I think this is my my feeling. So let's focus on actually what's your profile role like right now. I'm actually building stuff for myself, you know. So I'm building like a SaaS project. It's called Planero, and it's for managing deliveries. But the thing is, like, I just like switched it to sale, and I'm kind of slowly. I'm not that good in selling it, obviously, yet. So I have to actually start finding the customers. But also, like, I have to. My other role is a father and breadwinner, I guess, for my family. So I have to also think of that, you know. So that's why I'm actually doing also a couple of interviews, which basically, if I manage to actually make money on my own, then I will be happy and I will never go to any Google or anything like that. But if I don't, then, you know, I might need to go back to corporation for a bit longer. But I'm actually planning to build like apps, like small apps for, you know, for small amount of users, just and try to make it on my own. Yeah, and I'm a front-end developer, if that's a profile thing. I think like recently I did much more because of the AI. I deal much more, like I try to do full stack. I know like I think like comparing to most of the people, like actually know DevOps quite well. Like I can write my own, you know, pods and stuff, you know, my scripts for building and for deployment. So I think I can deal with that quite well. And I know the good old fashioned, you know, FTP and that kind of stuff. So I know like how to deploy websites and like on like multiple ways. So I think like you know, I never worked like as an expert there, and I never even read, you know, Kubernetes or wherever Docker documentation. But I think I could actually do quite well with that. Yeah, and the backend I tried a couple of times, and you know, with different results. I like right now I'm building thing with Python, which initially like Python and Django, which initially I actually set up basically based on like some video tutorials, and then like you know I used AI to actually expand on it. So that's kind of thing. I think it's yeah, I'm mostly front-end developer. But yeah, let's just do. Okay, I actually asked, like, I just told ChatGPT, which everything starts now. Those days with ChatGPT. So I'd say, I just told, like, I have 3 hours. I have basically 3 hours. Help me. And he or she, I don't know, like, maybe I'm sexist and I'm calling him a guy. He said to me that, you know, if you do it with JavaScript, it's totally fine for LeetCode. I didn't even like that. Okay. An interview care for more about your logic than the language. Okay. Here's JavaScript focus 3 hour prep plan with exact syntax patterns you should memorize. Ooh, yeah, that's a good. It's like school. I love it. You know, you just memorize things that you will never use again. This is very, very useful. But that's how it. I think that's how I feel about many jobs that are there. You know, like you just memorize shit and like, and then it's only used in the kitchen, like when you're talking with other engineers, just to pretend that we are actually smarter and like no not and to pretend that there's no problem with like business stuff or like you know we enjoy talking to each other because we talk about algorithms and there's no conflict in the team. So I usually like I see that this is how it works. So let's talk about algorithms, you know, instead of like why Joe is not talking with Jan, not talking to Jan. Memorize those. Don't think during the interview. Ooh, that's a good lesson. That's a good advice. Don't think during the interview. Okay, I will memorize that. So maybe I should just write it down. If it's a hash map, okay. Frequency count. Map get. Okay, set. Okay, sort. So we are just doing array sort. Okay. Okay, let's just go. So hash map is just like new map. Okay. And we can set things on map because it's an object, obviously, with some properties. And we can get things from map with a key. And we can check if it has. Okay. I don't know if it's like, can I be bothered? Like this is yeah, okay. Yeah, that's fine. Maps are useful, they say, you know. I've seen like them implemented twice. I never see them online. People actually using them online. on video tutorials or anything, unless it's about hash maps. So let's hash map is basically new map. And it has properties of set, key, value, and it has get, key, okay, and has key. Okay, I'm prepared with hash maps now, and we can obviously set a hash map. So this is wonder why is it this way. So it's a map. Okay, so we have a map. So why would you set it with get map c? This is confusing. I don't know why it's frequency count. I should probably ask, but I don't know. Okay, so we are setting things. New set. Oh, because there's okay sets. Yeah, obviously. I was actually recently asked in one of the interviews about maps and sets, and I said I don't use them. Why do I need to know them? Maybe I should know them. I don't know. Maybe I'm just like an idiot and I'm just telling everyone that, you know, knowing things is bad. But I find that you know, we focus on knowing those things, and then we forget that, you know, there are other questions to ask that people are really afraid of asking, and when you ask them, you know, you get the wrath of management. Okay, sort. Yes, sort. So we've got like array. So this is array sort. How set actually works? Because it just showed me new set. Yeah, okay, JavaScript set. Let's see. I didn't as I'm saying, I'm not using maps and sets. I'm just using arrays. They're easier for me. JS. How the set constructor. Set objects are collections of values. Values set my occur ones. Okay, let's just see what's the difference between set and set, array, and what was the third one? That's not the list actually. And map in JS. I think there will be an article. While arrays and sets are used to manage lists of data, objects, object S, and map. Oh, okay, so map is just the alternative to object. Map is a key value. It's like in Python you get the thing. in Python we have yeah, I think we have also sets. Maps. No? Are there maps or tuples? Are there tuples in Python? Yeah, that's okay. I should probably program more. I'm doing too much vibe coding recently. I actually enjoyed vibe coding much more because much more is being done. But yeah, maybe I should actually learn that. So array and set are used to manage lists of data. Objects and maps are for map is basically key value per. I must say I used maps a couple of times, not that many times. I usually prefer objects anyway. You know, they say that I think like maps are actually quicker or something, but then when you are building thing where you have, you know, actually yeah, sometimes it's quicker. I've seen people turning things for maps to actually create more efficient things. Okay, so array sort stack okay, that's an array obviously. Push pop. Okay, so we are popping. So Q. Okay, push shift. Okay, for interviews. Okay, yeah. So this was 0, just basic syntax. Okay, so we just know that there are sets and maps and wherever, and arrays. Arrays and hash maps. Okay, parameters to master. 1 pass with map. Frequency counting. Prefix sum. Yeah, I think I've done this a while ago. To sum. Contains duplicate. Valid. anagram. Product of array except selves. Subarray sum equals k. Okay, okay, so we have to must do patterns. Okay. To sum JS template. To sum. What is it doing? We have a function here that implements a map, and then it runs through an array of numbers. Okay, so we actually push numbers into it and target. To sum. What is it supposed to do actually? Say this out loud. I'll use hash map to get on time. Oh, yeah, okay, yeah, those ONs and stuff. Yeah, I think I will do with quite badly today, but yeah, let's see how it goes. Do some function nums. So we are actually, what are we doing here? Difference target minus number. So if map has diff. Where's diff? Okay. Return map get diff. Map set nums. I don't really get that. Okay, so let's just try to do some. Okay, so we have a map here. So it's basically like the most optimal in the syntax, but it doesn't really explain why are we doing this. Sliding window. I actually learned this one a while ago. Two patterns. So do we have two? I don't remember how this works. Oh, we have one next to each other. When one next to other, and then we compare things. What was this? Hash map. Okay. Must do patterns. To sum. Okay. I don't really get that. Actually, I don't know what chat gave, you know. This is not really the best. This is like too generic, basically. I mean, this is not really specific. Like, I don't know why we are doing this here, even. Let's do some about. Let's do some doing and why is it? Yeah, okay, because I'm trying to see the difference. So if minim map has difference. Okay, so we create a new map. Are we assigned something? Okay, set map nums. So we are actually target minus num. If map has diff. What's diff actually? Okay, if it has target minus num I. Like. Oh, okay. So this is just to check if there is a there's something. Okay, I think I just got stuck now on basics actually. So this is gonna be fun today. We can see that it's gonna be fun. But okay, let's get back. Maybe I will get smarter with time. There. I just don't. I can't like. I think my brain doesn't catch why there is. Why are we doing? So we are actually checking if this part. If difference map has difference. And why, okay, let's see why it's there, because I can't get this. Really good question. This is exactly the kind of understanding interviewers want. Yeah, okay. Let's have nums, problem, simplified. We are giving an array of numbers and target. Okay, so target is this. And array of numbers on target. You need to find two different numbers that add up to the target. Oh, okay. So that 1 and 2, so 0 and 1 add to... because, okay. Like, how is it implemented, actually? To sum... Okay, I get that now. Yeah, because it didn't really explain. What does it want to actually achieve with to sum? What does it even mean, like, to sum? Okay, it's just like some shortcut. Okay, to sum, JS template. So we actually, yes, we have a map here, because map is good for key value, obviously. And then we are going through the array. We are just looping through our array, and we are checking if different target minus. Why it's minus actually? Because it should be a sum. So target should be... Oh, okay, target minus num. So how does it check, like, if it's this one plus the next one? Because we want to, like, two of them sum into... Because, like, basically I can imagine that... Oh, because we are with map. Okay, let's see. Okay, how did the map? So... This is it. So, okay, let's see, it's a first pass. On the first pass we have 0i. So in the first pass we do num has... Oh, okay, I'm starting to get this, I think. Okay, so we have a number minus target minus number. It has to be second number, is it? Shit. Oh, this is not the best. Okay. Because, like, I would implement it differently, obviously. I would just check 1 plus target equals num plus I. Is it? If target equals that, then return this. Yeah, okay. And it's also on, I think. It would be on. Yeah, okay, let's go further. I think, like, I'm not really learning here anything. Yeah, I'm just, like, on the first algorithm. I'm just do some... Basically, I'm just trying to figure out why it's better this way. Because I would actually implement this, like, if I want to check if two numbers are actually sum of like, if target number is a sum of two numbers, I would just say... this number plus the next number. Because it's target minus... Is it like two next to each other? Again, like, let's go back. Oh, I have 4 people. Wow, what a brilliant podcast here today. Yeah, I'm just, like, preparing for this thing. I don't know if I can even, like... The thing is, like, I'm not really learning I don't really use algorithms that much. I think, like, I was saying that there was one occasion where I could have used algorithm, and it would make my application fraction quicker. But the problem wasn't actually my algorithms or my code as an agency. So that was a bigger problem. Okay, so to sum, you are giving an array of numbers and target. You need to find two different numbers that add up to the target. Yes. Oh, okay. Yes, okay, I need to find, but, like, does it mean that I can do this and this one? Okay, does it have to be yeah, okay, like, for example, for each I or each j, yeah, on square, we store past numbers in map. Here we have a map and then target minus nums. If number has... Yeah, I don't get that actually very well. I don't work with maps that much. return. Okay, so we return get needed and I. But okay, we are returned here. Yeah. Try Gemini learn. Maybe. Learn. Gemini learn. Gemini AI for developers. I'm running out of time. I'm gonna learn another tool now instead of learning the actual code. Actually, like the to sum is actually harder for me, despite it's probably seen as most trivial. It is actually not that hard if you think of it, because you just like you can do 2 loops. Like there was two for loops, but okay, where is it? Okay, I just like I script. Yeah, like I never use actually Gemini, and I can see that Gemini learn, so I can see that it's I don't know where it is even. I just close it. Is it here? No. Gemini learn. Where is it? Is it here? Gemini learn. Learn English with AI-powered lessons. That's probably not this. Where should we start? No, the second. Okay, that's the one. Okay, that's not. Can you to me how to sum works? Like, yeah, I think I know how this actually algorithm works, but the thing is, like, I would do it with, like, I know, like, you just sum up two numbers into target, but the thing is, like, I'm kind of murky. Like, sometimes I have actually like it's like the problem I have, even like which is a bigger problem than not knowing some of the algorithms, is I actually, like, when you know more, then you start building this task into something much harder. So you start actually like complicating it instead of just like trying to find the simplest solution. I'm actually like often like, okay, the simplest, yeah, I know this is the simplest solution, 2 loops, but then yeah, what if this happens? You know, what if this black scenario happens here? And I try to already, before I actually start writing it, I'll try to optimize it in my head before I even like, you know. Wow. Tools learn, okay. Yeah. Here? Tools learn. Tools learn. Deep research. Create images. Canvas. Oh, it can create images. I'm actually much more interested in this part. Guided learning. Because ChatGPT told me that I have to know 2 sums. And I think I sort of know, but then I probably, like, on the interview I'll get stressed and I'll just fuck it up. But that happens sometimes. We fuck up things. The 2-sum problem is a classic coding challenge, often used to introduce a concept of time versus space complexity. Essentially, you are given a list of numbers, an array, and a target number. Your goal is to find 2 numbers from the list to add up. So they are actually anywhere in the list. So it's not like, because this, I thought it has to be this one, then the next one, for example, the two consecutive. But it's actually any 2 numbers. So can it be? Yeah, okay, that's fine. But like the thing is, like, we check every possible pair of numbers. Yeah, so the brute force is easy, obviously. So it's 2 arrays. My final exam is on 24th January. I started preparing for this exam 2 years ago. Whoa, 2 years to actually what's? Oh, okay, because this is university, obviously. So much changed in 2 years. Like, how can you prepare? Like, how is this exam will be relevant to actually your career? I mean, you will have a paper, obviously, some sort of paper that will actually prove something, that you actually spend many hours of something. But how is it actually useful? Sorry for asking those questions, but like, sometimes I also spent many years on learning things that are actually unnecessary. So it's not like I'm not... Okay, one pass optimization. We use memory trick hash map to find an answer. Just one look through the list. Yes, but does it have two consecutive numbers or any numbers in? Yeah, because I don't even get how the map is actually solving the problem of two non-consecutive numbers. Or any two-num array. Yeah, I might be actually dumb, you know. For example, in an array, if the target is 13, the answer would be the number 10, obviously, yes. For example, okay, in the two-sum problem, the two numbers do not have to be consecutive next to each other. They can be two distinct numbers at the position in the array, as long as they add up to the target. Yeah, like I think like you guys really enjoy me like struggling with this, like these silly problems, and coming up with excuses why I don't know them. We just don't use them in programming, I think. For example, you usually build prod to actually, you know, check something in the database, display something on the page, and then, you know, do something as well. Like, but I don't know actually if I ever spoke to any engineer that actually wrote an algorithm. Did I? And I worked with like really advanced people, like with people that are doing advanced things. I'm trying to think, like, when did we write an algorithm at work? Maybe because I'm a front-end developer and like mostly we do like display and like visual stuff, but I don't know. We get admission for engineering colleges on basis of this exam. Yeah, this exam sounds quite important. So I'm not surprised you are learning so much for it. But yeah, as I'm saying, like it sounds like something that we learn just to learn, and I did a lot of that in my past, and I'm still doing probably some of that. Sometimes it's fun actually, but often it's not. The only common restriction, for example, for example, brute force is easy here because you just like check first one and then second one. Okay, so we have that. Is it like is it Boolean? Problem: the two numbers do not have to be consecutive. Yeah, like I'm not seeing how this map business works. Or maybe I do actually. No, because we have something saved in the map. Yes. Yeah, I don't really get actually. Jesus, I'm so dumb. Maybe that's why I didn't go to Oxford. Has difference. Oh, but this is actually but this is doing the same. Like, why is it? How is it smarter, for fuck's sake? How is it better than two arrays? Can anyone explain it to me? Because this is array. We are doing array here and here. You have to array through this map. So it's just pretend. It's just pretend that it's actually more efficient. Yeah. Because because difference. Oh, maybe not actually, because with map it actually like the key is actually yeah because the okay maybe not, maybe I'm an idiot here, because with map when you get, I think it's not actually mapping through it. If it's key value, is it working like object, I guess, that it's like key, it's directing to where the value is. Yeah, I do have an interview. I don't want to work for Google, but like the funny thing is, like, I might need to if my SAS will not work, you know. So the thing is, like, I'm sort of occasionally interviewing still. I don't have to go to work for a while longer, you know. I still have a couple of months that I don't have to actually make money, but I would like to, on the other hand. And I'm just talking to Google just to, I don't know, just to, why would I talk to Google? Because they invited me for an interview and I thought I would try. And I've never been on interview to any of the FANG companies, you know, the Google, Microsoft. I've never been to any of those. Amazon, Netflix, no, none of them. I spoke to Netflix once, briefly. Google, I think with Google I kind of also spoke many years ago with some recruiters. I actually had like offer, like real offer from Samsung, for example, but it's not FANG. But it's probably the size quite comparable. What others huge company I could work? Bayer, that's the... I had the offer, actually, I had a money offer. Like, you know, just proper offer. Like, you can work for us for Bayer. That's the medicine company. Bosch, or I think there was a Siemens and Bosch. This is the German, you know, they make a... I think it's Siemens, Bosch, and like there's a couple of those, you know. I think there's one more like that, you know. Yeah, so those, you know, I think like that were the biggest. But I've never been actually interviewed for you know, Google or Netflix or anything like that. So that's my first one. I actually hate that kind of process of like, I think it's a waste of time to actually ask people about algorithms too much, you know. But yeah, that's actually today, and I sort of ignored it. I didn't really care. Yeah, I would go and study. Yeah, good luck with your studies. Good luck with your exam. Probably you would do better on that interview than I do. If you are studying for like 2 years for some exam. Yeah, I think like I'm the dummy here. Yeah, okay, I think I know. Yeah, so this is more efficient, yes, because map is actually just like it's using like how is it called? It's finding it by reference. So by reference, and then we check that check if the map. Yeah, I think it makes sense actually. This is actually pretty smart, to be honest. So I wish I wasn't that, you know. So like if I was asked like without actually preparing, if I was asked for this question, I would just write 2 arrays and I would say I don't know. But then like this is actually smarter because then you actually work with and this doesn't have to be map. I think it could be object as well. Yeah, you could do object. So the key would be a number, but then you would have to convert the key into a number. So that's why they're actually using the key value. That's why they're using map. Okay, let's move on. So let's say I kind of know TwoSum. So I'm actually like super smart now in this one scenario. So okay, I had an hour, so maybe I've actually like I didn't learn that very well. I sort of glanced through it. Okay, so I didn't actually write this code. I just so I will have to memorize it. Maybe just I will write it down. Just write it down because I don't know. TwoSum. Actually, the most important bit is here. Is this one because and actually this one. Like all those 3. All those 5. Yeah, other than that, it's just a function. All those 5, because you have to obviously establish map, but like that's something that you have to do, otherwise it's not gonna work at all. Then there is a loop through all of the items. Then we're changing the difference, and this is actually the smart part. I like this is actually funny because okay, we are checking the first item. So the first item was in this case was what was it, 2 or something. And we had 2, 7, and they would make a 9. So then we divide. Yeah, this is actually very smart. So we are checking if this, the difference, if it's anywhere in the array, and then we exit it. That's really, yeah, that's good. That's smart. Otherwise, we just set it. Otherwise, we just set it to a number, and then we go to the next one. Yeah. I wish I was this smart to actually write those algorithms. And I wish I ever used them later, because then I would just like write. You know what I will do? I would just write an array with array, and maybe it will not even matter because I will have 20 items. And this part, and like I remember I was like, actually I talked about this like ON and like this, how is it called even? ON, I think it's O. Yeah, it's called O. Yeah, I talked about it like maybe 3 times in my career, and like twice after I learned it, and just to actually sort of pretend that I'm smart. So I think like that's also not that necessary. And I spoke, you know, I had many conversations with like architects and stuff, and like they don't talk about algorithms. I think they just see it as a, you know, it's somewhere there. Like they probably learned it at some point and then forgot. Like me, you know, you are there just to, like, the algorithms are there to learn and then to forget. Okay, let's just go sliding window template. This one is actually can be quite useful, I think. Again, like I don't sets. I usually use other stuff. How was set actually working? So we just had like a set here. Let's just remind myself how the set works. Set. Set object lets you store unique values of any type, whether primitive values or object. So how is set different than? Yeah, you could do Python on. I'm gonna do JavaScript because I'm most familiar with JavaScript, and with Python I've been doing Python for the last few months only. So, and mostly AI. So like I think I'm a Python base. You know, I'm a junior, like a huge junior in Python. So. Yeah, I could probably, like in Django, set up like basic models and views and stuff, but like, actually, yeah, in Python, the thing is with Python, it's just like familiarity also. Like if you, yeah, you just like have to remember that a couple of types are slightly different. You know, you just use tuples here or wherever, and yeah, it's just okay. It's not that different. We too are not that different. Like James Bond, we are not that different. So like this is how. Sorry, this makes no sense. I would have to. This is a kind of joke I would have to explain for like a couple of minutes, which would actually defeat the purpose of saying a joke. Okay, let's get back to my. Yeah, the set objects. How does the set difference? Ooh, they're cool methods actually. Yeah, I don't know if I used sets that much. Like I think I used them twice somewhere. What role are you interviewing for? I don't really know actually. I don't remember actually. I think it's like a engineer or something. Let's see. Okay, let me just drop it. Oh, sorry, not YouTube. Gmail. I think it's some sort of engineering job. Maybe front-end developer. I don't remember actually. Yeah. Yeah, I have it somewhere in email. Sorry, I'll just check it. I think it's here. No, not here. This is out of office message. I don't know. I don't know. The thing is, like, I think what they are doing in this case is like if they like you and if you do those algorithms well, they will just assign you to a team. There's probably a gazillion teams that you could be assigned to, and it might not even matter like whether you actually what you know. It's just like, okay, you work here and speak to those guys and see how it goes, and maybe you will build something. I think that's how it works in Google. But you know, I'm just guessing. But the thing is, like, the bigger company I worked with, if the companies were bigger and bigger, the more diluted it all got. So like my role would be less and less like important, and like then it would be more about, I don't know, like sometimes it would just not be like, I wouldn't be building stuff even. I would be just talking about building stuff and nothing would be built for many months. So that's actually how I see the big corporations. And you could be hired for one position and then do nothing in that topic for many months, and maybe occasionally do something in that topic. I think that's how it works with big organizations. And if you actually prove to be good in management or something, they'll just move you. So yeah, that's the role. I can see. And actually, like, to be honest, I would rather. How many years have you been coding for? I don't know. Like, I've been, I would say probably 15 on the market. You know, so I've been actually doing like a software engineering for 15 years. And then, you know, there was university, and even in high school I would do some coding and some stuff. And I don't know if I can say like HTML and stuff, because then it would like expand. This number would actually you know, increase to like 25 years or something if we talked about HTML and CSS. You know, is this coding or is it just scripting? But yeah, like with that kind of technology, I've been building websites for 25 years almost. So, and you know, but like apps like with logic and stuff, probably like 15 years. Or maybe 10 actually. Because then I moved from web and graphic design, where there was some logic obviously. Like I would do some templating in WordPress or in actually Umbraco, more even. So there would be some logic there, like you would do some loops and stuff. But that would be, yeah, so that would be like 15 years ago. I'm in Poland. Not far from Warsaw. I'm like in a really nice place outside of Warsaw. I can show you. This is where I am actually. Let me just show you where I am. This is my neighborhood. Am I showing it? Yeah, I don't know. I can't see it. Okay, so this is where I am. Oops. Yeah, so this is me. No, back to the internet stuff. Okay, back to, so I couldn't really figure. Okay, what was the difference between set and object? Do I remember? Between set and object. Yeah. See, you can see how often I do sets. Yeah, I know, it's beautiful. And like if you go this way, that way, for like 500 meters, you have this big river actually, called Narew, and very nice place. You know, you could even have a boat there and just like sail. So it's like that big. It's like it's very like this place is actually this. Okay, where I am? Yeah, it's nice area. It's nice area. Very flat. So if you like mountains, it's not that, but it's still nice. Where are you? Sorry. Where are yourself? Yeah, I'm in Poland. Yes. As you could see, the snow and stuff. You know, that's Poland for you. Set is an object. Set objects are collections of values. Okay. A value is set may only occur once. So is in object it can occur multiple times? Okay, yes, it can only. Okay, that why it's actually. Yeah, which part of India? I think I get like lots of fun. I get fans from India. You know, there's lots of people on my, you know, when I'm talking from India. Like half of you guys are from India, which is cool. I like it. You know, you guys are actually doing quite a lot of programming and coding and stuff. So I can see that you actually think a lot about technology. Yeah. So okay, that's why in set it's only once. Yeah, but is it sorted or something? I like this actually. I should have been using actually sets more. I mean, the thing is like I'm not coding anymore almost. I'm doing like you know, I do quite a lot of vibe coding those days. So like it's I don't know if I need to learn sets even or maps. You know, it's just like Yeah, so set looks like an array, but it's with unique values. So this is how it actually is. Yeah, because even the implementation, it's like an array. Map is array of arrays, but with unique, with first value is a key. It's probably like it's probably working like an array anyway. It's like a 2D array, yeah. South India. So it's probably a bit warmer than here. In my place, it's -8 today. Centigrades, obviously. -8 centigrades. Yeah, okay. So I'm learning stuff. I was actually like, I was on another interview 2 days ago, and it was also very theoretical. I'm allergic to that kind of stuff anymore. I don't know. I even didn't prepare. And I like, you know, I kind of botched even those questions about sets and maps. Like, I don't know. I just, like, I don't use them. I don't care. Seriously, like, this is, like, if you want to be an engineer, this is not what we should be doing. Shouldn't really be worrying too much about sets and maps and stuff. It's just like a, you know, it's like your favorite color, I think. Most of the time it brings nothing. Okay, yeah, let's do the second one then. So we had the sliding window, 2 pointers, must do. Best time to buy or sell stock and sell stock. Longest substrings without repeating characters. Oh, okay, so we did get that. Valid palindrome. I don't know what's palindrome. I read about palindrome many years ago, and I don't really know what palindrome is anymore. But okay, I don't care. Okay, let's not spend too much time. With right and shrinks with left. Okay. So this is probably the smartest. That's okay. Let's just implement. Okay. Let's look into window algorithms now. Can you how they work? Yeah, okay. I just can't think of anything smarter. So we have this actually. So the left starts with 0, obviously. We have our set. Okay. For right 0. Right is smaller, sorry, bigger than is smaller obviously than left. Okay, makes sense. Okay, we start with 0, normal. Okay, there's nothing unusual in this array. Ooh, there's another array. What's this one about? So I'm probably guessing that this is the smartest way to do it. Oh, okay, because we have a value here, and now from here we start searching the second value. But why do we set delete? Oh, this is actually, so while set has right value, okay, so right is 0, okay. Delete left plus plus. Okay, set add. Dude, this is like, I don't know, I know this is the smartest way to do it, and it will take me now it will take me another 10 minutes to actually understand why it's actually that good. Because here, obviously, like, you go first loop, and then you are checking while set has right. Okay, so while set. This would be better if they actually gave example of, like, with real, like, array. Yeah, okay, so let's... Sliding window algorithm is a clever way to handle problems involving lists. Yeah, I actually learned that one a while ago, but I forgot it. Or like, I think I vaguely understand that. So let's be back to learning. Array of strings, where you need to look at the group of contiguous next to each other, contiguous elements. Think of it like moving, magnifying. Yeah, okay, I get that. Actually, I know how the sliding window works. Just learn the algorithm and that's it. Let's not really get too deep, unless you want me to actually look closer into it. But I don't think you actually. So 1, 2, 3, 1 plus 2 plus 3 is 6. 2 plus 3 plus 4, 9. Okay, so imagine you have this array and you want to find sum of every 3 consecutive numbers. Okay, 1, 2, 3. 2, 3, 4. 3, 4, 5. Okay, so you actually go, first item, second, third. Did you notice that we added 2 plus 3 both times? Yes. In a huge list, recalculating that middle part millions of times makes computer very slow. Okay, yes, man. Makes sense, obviously. We're never gonna use it, obviously. We're never gonna have this list. Or maybe one time in Google's history they had that problem. And that's why they're asking everyone now. How the windows slide. Instead of recalculating, sliding windows technique uses a simple subtract the old and add the new. Window 1. 1, 2, 3. Okay, slide. Move the window one spot. Okay, so yes, it makes sense. Okay, now I get it. So you actually remove one item. So you subtract in this case, we just, instead of recalculating this every time we move the one forwards, that would be less efficient. We just subtract this and add a next one. So add 4 in this case, if we are moving. So if we moved, we actually, we subtract the first one. Okay. Yeah, okay. Like the previous sum, subtract the 1 and then add 4. Yeah. 2 main flavors. There are 2 ways this usually works. Fixed windows, the size of the magnifying glass stays the same. Find the max sum of exactly 5 numbers. Yeah, okay, this is easy. Maybe not easy actually. It's not that hard, I think. So good. Okay, I got sliding window again because I'm sure I learned it. I've been actually doing. I've done that, but on different examples basically. So there was a algorithm there was a course that was showing how to do that, and yeah. Okay. The fixed window. Which one? Okay, so there's the fixed window. Usually works. The size of the magnifying glass sizes are the same. Find the max sum exactly of exactly 5 numbers. Okay, so you just move by 1 and then you save the highest. If you move by 1 again, it's higher than the previous one, then it's the higher. Okay, I think I could actually. I will probably botch it on the interview, but maybe not. Maybe this time I will actually get that. So let's go forwards. Okay, I think I might actually do this one. So I just don't like this implementation, you know. So you just so we're like, okay, we have. I'm wondering. I'm just trying to figure out how this set add. It's okay because I think like there are 2 different examples, and this one is because they don't give data here. I don't really know what they're actually trying to achieve with this array. Right and 6 left. Okay, stack. Must do valid parentheses. Yeah, okay, I've done this. I've done this actually example on. There's this website called Code Wars ages ago, and I think I brute forced this as well. So yeah, I've done like 2 arrays and like probably yeah. This is actually smarter, obviously, because you just do 1 array and just do. What are you doing here? So valid parentheses. Yeah, okay, let's just... yeah, okay. So we have our map, and let's see of S. C of S, okay. In map. So that's a value. In map. If this is in C in map. How does in works? Stack pop. So not equals shit. Like this is all again like it's smart obviously, but I can't get no. Let's do the Google. Okay, makes sense. Next. Let's do stacks now. Stack. No. Yeah, the chat is not very friendly for my brain. Like sometimes I just need much more context. I just need to, like, if it just doesn't give me values, it just kind of assumes that okay, oh, this is something, and you then imagine what you have here. It's really hard for me to actually and I actually, what's in? Do I know? Do I remember actually? JS if A in B. What does unusual if? Yeah, okay, yeah. Am I familiar with in? No, I'm not actually. I have, and someone just stumbled 14 years ago, so like I've been in this thing for more than that, or almost that actually, or like depending like how we count. Just stumbled upon the following web page and somewhat integrated the use of the in. Yeah, okay, so the in operator checks if the property is defined on an object. Okay, yeah, makes sense. Wow, I didn't, because I would just do it differently, you know, I'll just say object and then value equals something, yeah, double equals or triple equals. In this case, the code is checking if autofocus is property of new element. Yeah, okay. Yeah, okay, so if that's, no, this actually checks if the property is there. If the property is on the object, okay. Basically, I would do it, you know, a dot b equals, is it defined basically, a dot b or maybe, you know, if this is actually there, yeah, I think that's how I would do it. But like, okay, this is better, this is clear actually. Wow, I didn't really, funny, like I didn't really use that, or maybe I did. Okay. Crazy. Something is I actually keep on forgetting. Like there's just so much knowledge to actually learn in this topic, and it's really hard sometimes to stay up to date, I guess. Especially when those people ask you to learn algorithms again. Sorry, just checking something. I had to change the date of the event. It will take place 29th. Yeah, okay, good. Okay, if this value is in map, Oh, this is actually smart. So this is, the map is... Oh. So these are objects that we define here. So this is object, 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 object. See in map. So if this, so this is checking. Yeah, I'm just trying to figure out why. A stack is a fundamental data structure that follows the very specific last in, first out. LeetCode. Imagine a physical stack of cafeteria trays or a pile of books. When you add a new tray, it goes on the top. When you want to take a tray, you have to take one was placed most recently, so you take one from the top. So okay, to interact with stack, we primarily use two actions, push and pop. Okay, so we just add and remove the last one. Action pick, which lets you look at the top item without actually removing. Okay. So if we have a class with that, that makes sense. So we will actually implement the pick that would actually look at the last item. Stacks are everywhere in computer science because they are perfect for tasks needed. Undo, backtrack. Yeah, the funny thing is like you just use the library here, but like that's actually useful. Like I can actually imagine that, you know, when you do, when you're actually writing a list of steps you do somewhere, you know, like undoing page from one to other. So if I was writing my own router, that might be actually interesting. That might be useful. So just like go to the next one and then delete the last one, or like if you want to undo something. Yeah, Control Z. Browser history. Yes, we can do that. Function calls in programming. We obviously don't implement that ourselves because we have a library here that will do it for us. But if there is no library, if there is for some reason we didn't actually figure out how to use that library, or like we are too lazy to actually, I know, like no, we are not too lazy because we are too lazy to actually use this ourselves, to build it ourselves, and like it might be actually useful to learn. I don't see the thing is like when I actually sit down trying to learn those things, I actually stop thinking about how I can like what sort of problems I can solve, or how I can actually make, you know, earn for my family. So I start thinking about how stacks work, and this is actually very niche knowledge. It's like other day I was thinking like why, like because my wife was talking about learning stars and stuff, you know, like not stars, but like how the space works and stuff. You have black holes and stuff, and it's actually fun knowledge, but it's very unnecessary. It's like a luxury knowledge, and I feel like some of the stuff is luxury knowledge. It's something that is not really used by anyone. It's just something that you actually have as a luxury. You just have extra time to actually play with it, and you can spend like watching TV, or you could just learn this. This is, yeah, so algorithms I see as a luxury knowledge. Something that you don't need for almost anything. You might actually stumble on them once in a while. And like being in last 10 years, I actually stumbled on a situation where knowing better sort mechanism would actually be useful. And then never actually again. Because mostly I would just get data, like mostly the problem on the project is not the efficiency of our sort mechanism, it's the efficiency of our interaction with our manager and with, you know, other clients. This is actually where the problem is. And we like to actually focus on something that is abstract, like those algorithm things, like sliding windows and, you know, call stacks and stuff. Let me ask you actually, Oh, okay. But I wonder like how stack works in this case. I don't really get this stack actually. Map equals. So this is some sort of object, yeah? Or they call it map, but it's an object. Yeah, okay. How would you expand on this? Yeah, expand on example. I explain how. Okay, so it's. I wonder like how it's checked. I just can't visualize. Like, okay, so is C the key or is it value? So it's a key, obviously. Okay, so off. So let off is giving you keys, not values. Yes, and in gives you values probably. Do I remember correctly? I always confuse them. Yeah. Can you expand on this example? Did I already ask? I need to understand more about what it does step by step. Yeah, okay. I don't know. I just can't really absolutely. The classic interview question: what is the problem? Is why we use this stack? We are giving strings like, yeah, okay. Every opening bracket must be closed. Must be closed in the correct order. Must be same type. And I've done this actually. Uh, yeah, obviously. Oh, so that's why actually, yeah, I get now why there's a map, obviously. So okay, actually, you are because like when you have multiple parentheses, you are checking if it's open and closed. Okay, okay. Why a stack? A stack is a list in which first out. Yeah, okay. Now I actually get this. Now I actually get this. Finally, took me like half an hour, so I'm supposed to have it in 20 minutes, and I'm actually not writing code yet, so I might be screwed actually. I might be screwed on this interview, but we'll see. We'll have fun. Defines function that checks if a string is a value. Yeah, okay, yeah. Stack. We are creating the stack and then we are pushing and popping things from it. Or like closing, opening. Yes, so we are checking if this one why is it in this order? Looping through a string, obviously, yes. We process one character at the time. So we have a first, yeah, so we have a key. If key is in the map, it's a closing bracket. Huh? Again, I already then pop it. Obviously, just remove it from the if pop not equals to. Yeah, I don't really get that. It's like this is too smart for me actually. I would have to. Okay, let's just do it. Let's just think it again. Let's read it. Okay, the line does three things. So we pop the thing first. Okay, and we check if not equals to map C. Tell us what opening bracket we expect. Why pop would actually stack pop? Not equals to map.c return false. No, I don't really get that. I don't get that again. Character is operating brackets. I'll grab a coffee actually. I think I'll grab a coffee. So it's a moment for a break for all of us, for all two of us. or 3 of us actually, because I can see there's 2 people. I can't think of actually, my brain is frozen. So okay, according to Google I still have quite a lot to learn. Yeah, okay, let's just go back to another. Okay, yeah. Trees, so stack trees. Even one solid traversal goes long way. Oh shit, this is actually stuff I learned and I kinda understood it at the time and then I forgot, and then probably like learn it again today, it will be actually freaking hard. Deep the BBFs. What was this? Maximum depth of binary tree. Okay. Invert binary tree. Okay, yes, yeah, I did. I'm sure I was learning both of those. And then I never used them. Okay, max depth. So we're actually checking if we are at the root, return 0. So, okay. If not the root. Max depth. Okay, if not root. This was the root. If we are not at the root yet. So this is just check. So we don't really have empty trees. Empty wherever. So max depth left, max depth right. Don't get that. Are we okay? Max depth. Oh, okay. Recursive function. Yes. So we calling this one to check if 1 plus max max. For me, the while is actually much simpler than recursive functions. They always like take me longer to read them. DFS, shit, like we should actually explain that better. Let's go deeper into that. Can you explain how this works? I promised I would go to grab a coffee, but I didn't really yet. Max depth function uses deepfs. It prioritizes depth first search. Okay, yeah. Okay, I knew that. Depth first search. Function uses depth first search. It prioritizes going as deep as possible down the breadth before moving to the next. Okay, so we go left, unless there is no left, then we go right. And then we have to, do we pop it actually from the logic? It asks what is the tallest height of my left child and my right child. Okay. The math, it takes a maximum of those two heights and adds one, counting itself. Yeah, okay, I think it makes sense. Base case. If it hits empty spot root, it returns 0. Yeah, breadth. Okay, so there are just two strategies, you know, sometimes it's not, none of them is better as far as I remember. The level order function uses breadth first search. It visits every node on one level, like a single full. The problem is that I will not be able to implement those functions now. Because I just like, it will just, everything will just get mumbled in my brain. And if they ask me about implementing breadth first search, I will actually have to think, and then I will just probably mess something up on the way. This is gonna be fun. Yeah, so it's gonna be fun, I'm guessing. The tool, it uses queue. First in, first out. The loop, it records how many nodes are in the current level size. Processes exactly how that many nodes pushing out in front of the queue shift. Again, I don't feel like I totally stopped feeling like doing this even. Patterns, which aspects? Maybe I should learn one of those at least. And I think I had like a Udemy tutorial where guy was actually explaining it very well. Oh, not Udemy. Let's just do YouTube. So let's do. Yeah, I was learning this, I'm sure. But I don't feel like actually learning it anymore. I think this Google thing might not work well for me today. Will be fun today. Yeah, this is not the full example anyway. Like, it's really hard to actually learn from this. It's really... Okay, let's just watch a video on someone actually explaining this, because I think I don't really... how to do... in JS... Graph traversal. Ooh, in 100 seconds. Let's see, actually. Maybe I will understand just after this one.
A graph is a nonlinear data structure that contains nodes and edges. A node, or vertex, is just a single unique...
Yeah, so this is actually one example where I wish actually I knew this search or this kind of... and sorting that kind of nodes, because I was actually working with nodes like this in the D3.js. But like, as I said, we actually lost customer not because of the algorithms or like the speed of the application, but we didn't speak to them. We just spoke internally, you know, talking about the problems that we had actually within the code, and we didn't really speak to the client, which was probably bigger crime than not implementing right algorithm.
Value, while an edge represents a connection or relationship between two of these nodes. Think of something like Instagram. Every user is a node. Every time you follow a user, you create a new edge connecting two nodes together. This is known as a directed graph because the relationship flows one way. The follower follows the followee and not vice versa. Now consider Facebook. Your edges in the graph are friendships. This relationship goes both ways, which is known as an undirected graph. Graphs can also be weighted, which means the node has some additional data about the relationship, like the distance between two airports. A node might also point to itself, like an airplane that takes off and comes back to land at the same airport. This is known as a cycle. Graphs are used in many real-life software products, and you'll often be asked to represent a graphic.
I was building a graph with D3.js, and like actually, like, yeah, probably like if I learned a bit about those, you know, like those search algorithms, my app would be slightly better. Would be actually fraction better. Would be better performant. Although we lost the customer because we didn't speak to him.
Code in a technical interview. One way to represent a graph is with a 2D array or adjacency matrix. Create one row and one column for every node. When two nodes have an edge or connection, add a 1 at the point they intersect. This makes it fast and easy to look up a specific edge or to add a new edge. But as a 2D array, it takes quadratic space complexity and quadratic time to insert a new node into the graph. An alternative approach is an adjacency list. In this representation, we start with a collection of nodes. Then each item has its own array of its neighbors. This makes it faster to iterate over a node's edges and is more efficient with memory, especially when you have many nodes and few edges. In your interview, you'll likely need to traverse your graph. One option is a depth-first search. Start with any random node, go to its first child, then its first child, and do that for as long as you can. When there are no more children, backtrack to the last node and continue the process. This algorithm is usually implemented with a recursive function. Another option is a breadth-first search. From your starting node, add all.
Okay, I think I'll just write down this DFS. Depth first, yeah. So what is root actually here? No root. Okay, return 0. Root is the tree. It's like to the array, yes. Var depth equals function root if not root zero. One plus max max. I actually don't get this this shortcut because max depth root left max depth. That's right. And I know I've done it actually. I've done this example before on some course. I've done this example on some course, and I think I understood it at the time a bit better than now. Yeah. Funny how it goes. When we learn those things, we actually remember them better. Okay.
All of the direct children to a queue. Once they've been visited, move on to the grandchildren and continue following this pattern in layers. This has been Graphs in 100 seconds, but hang out for a few minutes because now we're going to implement these algorithms in JavaScript. If you're new here, like and subscribe, hit the like button, open your IDE, and get ready to go beyond 100 seconds.
Let's see that.
As a developer, you'll come across all kinds of different real-life implementations of graphs. I mentioned Facebook's social graph at the beginning of the video, and they're commonly used for recommendation engines, like Yelp, for example, to connect businesses to users to reviews, or Netflix to connect the movies that you watch to movies that you might want to watch in the future. They're also used to represent geographic data. For example, on Google Maps, you can think of every intersection. Over the next few minutes, we'll implement a basic graph in JavaScript based on the flight connections between airports. In this case, every airport is a node, and the edge represents whether or not you can fly from one airport to another. This edge could contain additional information, like the kilometers between the two airports, in which case that would give us a weighted graph. The routes between two airports could be one-way or two-way. When they go one way, we have a directed graph. If they go both ways, it's an undirected graph. For this demo, we'll try to keep things simple. We'll make an undirected graph, assuming that when an airplane has a route, it can fly back and forth between the two airports. It'll be unweighted, so the routes between the two airports won't carry any additional data, and we'll assume cycles are not possible. The first thing we'll need to do is represent our graph in code. Most programming interviews will have you write code in whatever language you prefer. We'll be using JavaScript here, but the most important tip I can give you is to simply explain your thinking process as you're writing your code. Most technical interviewers are trying to get some insight into your thinking process and care less if you write perfectly formatted code. Let's go ahead and walk through a few examples. You might get a question like this. Here's a list of airports and a list of routes connecting these airports. Now represent this data as a graph. So given this data, we can represent the graph in two ways, a matrix or an adjacency list. A matrix takes up more space, but is generally easier to visualize and represent. because it's just a two-dimensional array filled with ones and zeros. Now looking at this data, I can see there are not very many routes relative to the number of possible combinations between these airports. That means our matrix would be very sparse, or in other words, filled with a bunch of zeros, and take up a lot of unnecessary space. And it would be less efficient to iterate over and search through. Therefore, I choose to represent my graph as an adjacency list. We can implement an adjacency list as a set of key value pairs, where the key is the name of the airport or the node, and the value is an array of edges, or the other airports that it's connected to. We could implement this with a regular JavaScript object, but a better option might be a map. When you're doing algorithm problems in JavaScript, a map tends to be a better option than a regular object. It has some additional API methods that can be useful for problems like this, and it just behaves more like a regular dictionary or hash map that you'll find in other languages. So the map is our graph, and at this point it's empty. The first thing we'll do is define a function that can add a node to the map. This function takes the airport code as its argument, and then calls adjacency list set on the airport, and starts it off with an empty array, and that's all it takes to represent a node on the graph. To add an edge, we need to update the entries for both the origin airport and the destination. First, we'll grab the entry for the origin airport, and then push the destination onto its list. And then we'll do the inverse of that by getting the destination and then pushing the origin onto its list. And that's our entire API for building a graph as an
I think I just lost myself
and then push
here.
the destination onto its list.
So accept adjusted list. It's a map, obviously. Okay, so we get origin. Oh, okay, and we push destination. So we just
and then we'll do the inverse of that by getting the destination and then pushing the origin onto its list. And that's our entire API.
Add edge. Get origin, push destination. Get destination, push origin. Don't get that. Shit. Okay.
Yeah, if we're building a graph as an adjacency list. The next step is to use this API with our source data. We can loop over the airports with for each, and for each one, call the add node method to add a node to the graph. Once we have our nodes, we can then loop over the routes and add an edge for each route in that array. That function takes two arguments, so I'm going to use the rest syntax here to destructure them. Now you can go ahead and console log this graph by running it in Node.js, and you should get an output that looks similar to this. Congratulations, you just got through the first part of the interview.
Okay. I didn't. I just watched him actually doing it. Okay, we get origin, push, destination.
When you're doing algorithm problems in JavaScript, a map tends to be a better option than a regular object. It's an output that looks similar to this. Congratulations, you just got through the first part of the interview.
Get destination, push, origin. No, I didn't get that. How did we actually traverse that list? Oh, airports for each. We add a routes for each route, add edge. Destination, push, origin. How did it do it?
Yes, and you should get an output that looks
okay, add edge because
for them. Now you can go ahead and console log this graph by running it in Node.js, and you should get an output route in graph for the
okay, let's see the
now you can go congratulations to implement it.
Logs JFK. How did it actually? I don't know how it's. How is this? Where did we get that information from? Because that wasn't in the array.
Algorithm to figure out if there's a route between Phoenix and Bangkok. And as you know from earlier in the video, there are two main ways we can approach this: depth first search or breadth first search. I think the easier one to understand is BFS. You know, in order to search a graph, you have to start somewhere. In this case, we'll start with the Phoenix node.
Yep.
So we need a function that takes a starting node as its argument. Write that out on the whiteboard or as pseudocode in whatever editing tool you're using for the interview. From the starting node, you'll want to visit all of the children and see if any of them are Bangkok. If not, you'll want to visit their children and do the same thing. And then you'll continue doing this in layers until you find the airport you're looking for. We can represent this process as a queue, which in JavaScript is just an array where the first item in is the first item out. And of course, the first item in your queue should be the starting node. Now, while the queue has items in it, or the length is greater than 0, we'll grab the first item in the array using the array shift method. This method will mutate the original array by removing the first item in it, and then return that item to us here that we set as the airport variable.
Okay, yeah.
Our next step is to grab all of the edges for this node in the graph. We can do that by calling adjacency list get with that airport name as the key. That'll give us all the destinations for the airport or its children, so we can loop over them and add them to the queue as well. We can also go ahead and log out if any of these airports are Bangkok.
I really suck at some of those algorithms. Some of the stuff I kind of get, but like some of it is really actually way above my head. So I'm actually kind of watching this guy, who is actually doing pretty good job. I think this is one of the best. No reason. I mean, there is a reason why there is 4 million people subscribed to this channel. But it's Fireship, yeah, he's good. I like his 100-second things. Sometimes if I want to just like see how the thing goes, like how the new software, how new library works, I can just have a glimpse.
The airport we're looking for.
Okay, so for destination, all destinations. So we check if there is a value in that key. This is problem with me actually sort of very badly actually knowing maps, because this is obviously with map, or yeah, with. I mean not badly. I kind of know maps, but like I'm not that familiar with methods that are actually there. Although he's actually he's using here array, didn't he? So we have this airport here, queue. Oh, and then he's gonna push it again to the same function.
Now, one major problem with this code at the moment is that airports have many interconnected routes, and that means our algorithm will be visiting the same nodes over and over again. And in our case, this creates an infinite loop because the queue is never emptied. We can avoid that by keeping track of the airports that we visited in the past. An easy way to do that in JavaScript is with a set, which is basically an array, but all the values in it are unique. We set it up as an empty set when the function is first called. Then we can use it to set up some conditional logic in our loop. We will only enqueue an item.
Yeah, okay, I'm getting lost now. This was too quick. The funny thing is, like, I think I've done this algorithm, ages ago, and I think I understood it much better than I'm doing it now. I spent like a couple of days actually back then learning some of them. Then I forgot because I didn't use them. You'll use it or you lose it. Maybe you just have to really, really learn it, like really in your heart, have it in your heart, and then you can use it properly. But the thing is, like, then you will actually look for, like the way I see it is like, if this is actually something that I really focus on, I will be looking for any problem through that lens. So I'll be like, instead of trying to see if actually this is even necessary to be solved, I will be just trying to solve it always by this algorithm, or like a couple of algorithms that I know. So that might be that's a risk I always see.
If it does not have this destination. A set has a has method where you can pass a value to see if it exists currently in the set. And then we'll mark the destination as visited by adding it to the set. Then we'll move the line of code that adds this item to the queue inside of our condition here. So
yeah, and the thing is, like, I'm just watching this guy doing this, and the funny thing what will happen during the interview is, like, they will ask me to implement this, and I will have my brain will be empty. I was start thinking, okay, what was the problem? So maybe I should actually start learning what's the, instead of just like how he solves it with the code, because I'm not gonna memorize it now. I should actually probably learn his, like, as a pseudocode. I think I would do better with that. Although, yeah, because here it's just like, okay, let's use this, and this has a good hack.
And you should get an output.
There is a good hack where you can just check the value, and then there is this keyword that's like I'm kind of vaguely familiar with. yeah, I think that kind of learning is not very efficient. But I think like I'm actually getting to like 2 hours and not really getting anywhere. And I'm wondering like if this even learning is not too late. So maybe I will actually get back to working on my product, go to the interview, try to wing it, um, eat, eat the failure, I guess, and then be back on my product. And maybe I'll get like if I will be looking for a job, I still have some time, and maybe the Google is not really a place for me. Yeah, this is me, negative me talking through me. But like I think like that's like the reality is I didn't really prepare well enough, and unless I cheated, which I don't want to, I think that would be stupid. I don't really want to. I don't think like I will actually benefit that much from going through all of them. Climbing stairs. Yeah. Let me start with brute force solution and then optimize. Yeah, okay, I might try that, Let's just try brute force, improving using known patterns, codes track clearly. Yeah. Yeah, I think I will actually give up for now. I will be back to working on my product. I think it's more important for me. And maybe Google is not something for me. Although, and I'm not that excited about actually working for Google, to be honest. So if I actually somehow, I will actually get through the interview somehow quite like better than I expected now, which I don't think so. Then I'll think of it. But I don't know if I actually even want to work for Google. Maybe that would be good, for CV, but like maybe not actually. Do I need to actually improve my CV? I think like that's another question. Like, do I need to even think of CV that much? Yeah, CV is just like a piece of paper. Someone will look at it or not. Okay. This is a philosophical questions which I will actually be pondering over the next hour or two. But yeah, thanks for coming. Actually, I don't know if it wasn't even like a waste time, to be honest, because I sort of realized that okay, this is too late. 3 hours is too late, and unless I wanna memorize some of the solutions, which is not very good, I think I got those two first or three, yeah, first two or three, sort of, and then like it's getting a bit more murky with each of them, and I think like my brain will get tired, and I will stop believing in even any chance of actually getting it well. So I think I'm gonna go and grab a coffee, have a talk to my wife, eat something, and maybe be back later for my product, and I will go to the interview, which will probably go. If it goes average, I'll be happy. Yeah, or if it goes okay.